Hey guys, this is Mike Keenan here. Today I'm going to go over network models, what they are and why they were made. So you have two main network models that you're going to hear about and they're going to be on the CCNA exam. You're going to have the Open Systems Interconnection Model, OSI, and you're also going to have the Transmission Control Protocol, Internet Protocol, otherwise known as TCP/IP. So starting here with this top one, the OSI model, it was developed by the International Organization for Standards, ISO. Don't ask why it's ISO instead of iOS. Maybe they made it that way so it's easier to remember. Just take OSI, it was developed by ISO, just flip them and you'll be able to remember them just fine. They were officialized in, or the OSI model was officialized in 1983. The TCP/IP model was developed by the DoD. It was mostly by DARPA, by research from DARPA back in the late 1960s. The first practical test between networks using the TCP/IP model was back in 1975, and it was officialized in 1982. But why do we have network models? What are they used for? Well, here's a list. Number one, it makes network concepts less complex. It breaks very complex ideas into less complex subcomponents. It allows for the ease of education. That way I can be here teaching you this in a way that makes sense. It allows for multiple vendor technologies to talk to one another, otherwise known as interoperability. It allows for standardization of different network technologies between different vendors. It allows for modular engineering of software implementations between layers, and it provides a common framework for developers. What all of that basically means is that network models break down complex subjects and make them easier to understand. They make them easier to develop technologies for, especially when you're going between vendors. So back in the day, they had IBM and Apple and the DoD all competing with each other. And, as far as the commercial side goes, you would have IBM and they would have to create their different network devices to be able to talk to Apple devices and be able to talk to other vendor technology devices. What this allows for, what a network model allows for, is for IBM or for Apple to create a network interface card or a developer to write software so that it can communicate with other vendor technologies easily. There's a common framework, and not everybody is using their own proprietary concept of a networking technology. Instead, everything is unified so that they can all just talk to each other using one standard. So here are the main models lined up next to each other. There's actually two models here. One of them is broken out into two parts. You have the TCP/IP original model and you have the TCP/IP updated model. So this model here, the updated model, is the one that's used today for TCP/IP. Now over here you have the OSI model. Now TCP/IP eventually won out and put OSI to rest, but you still have to know the OSI model. In fact, many network engineers, to include myself, still use the OSI model when referencing network systems. So you'll see here, you have the application layer of the TCP/IP model, which encompasses the top three layers of the OSI model. And honestly, that made it a heck of a lot easier to be able to comprehend the application layer because it just doesn't make very much practical sense from a network engineer's perspective. Maybe a software engineer, maybe they can break it down more easily, but from a network engineer perspective, it's hard to wrap your head around the application, presentation, and session layers. So what they did was they just combined them into the application layer. So the OSI model down here, you have the application, presentation, session, transport layer, which matches up with the TCP/IP updated model, the network layer, the data link layer, and the physical layer. So let's take a closer look at the OSI model. So here you have the OSI model broken out into its different parts. You have the layers, they run from 1 up to 7, bottom to top. The application layer is layer 7, the physical layer is layer 1, and so on and so forth. Each layer has its own protocol data unit, and that's what protocol data unit, that's what PDU stands for. So here we have the OSI model, and we have representing on either side two different concepts. We have the applications that exist at each layer of the OSI model, and we have the application of the different file types and encryption, SSL being secure socket layer, SSH being the encryption technologies, and also the presentation layer does, so it not only does it do encryption and decryption, but the presentation layer also does compression and uncompression of data, but it also represents different file types like JPEG and GIF. The session layer involves program sockets and APIs. The transport layer deals with TCP and UDP, such as TCP 443 for HTTPS and UDP 500 for IceCamp. Network layer has the Internet Protocol, the ICMP protocol, which includes ping and traceroute, and it also has ARP, the Address Resolution Protocol. The data link layer encompasses the Ethernet. The data link layer is also sometimes referred to as the Ethernet layer, but it includes the Ethernet protocol. It includes point-to-point protocol and spanning tree protocol. And the physical layer, that's where your cables, your physical wires, and your hubs are going to be. It's also important to remember that routers are considered layer 3 devices. They are network devices. And switches are layer 2 devices. And then, of course, you have your hubs down here at the physical layer. Another important concept that we need to go over is the protocol data unit, otherwise known as PDU. So if we were looking at the TCP/IP model, the application layer, which encompasses, again, these top 3 layers, we have your data. So that's going to be your website, your web page being sent to another device. That's the web page being your data. Then you have down here at your transport layer, you have segments. Down here at the network layer, you have packets. So packets, what they're going to do is they're going to package up data sent to it from the transport layer. It's going to put a source and destination IP address on the packet, and then it's going to send it down to the data link layer. And the data link layer, you have frames. So it's going to put a source and destination MAC address on the frame, and then it's going to encode it. The data link layer is going to encode it and then send it onto the wire using electrical impulses that are being represented by bits. And I forgot to mention it, but the segment, what it does is it puts a source and destination port number on there. So if it's using TCP, or if it's using say HTTPS, it's going to put the destination port being TCP 443 and some random source port. Okay, so let's talk about layer interaction. We have two different kinds. We have adjacent layer interaction and we have same layer interaction. So let's first talk about adjacent layer interaction. So you have a network model, a protocol stack, we'll call it. You have the application layer at the top, and let's just say that we have the transport layer just below it, like in the TCP/IP model. And let's go ahead and draw one over here for the next example. What adjacent layer interaction means is that it provides a service to the layer above or below it. For example, the transport layer is going to provide a service to the application layer. So the transport layer is going to take the information given to it from the transport layer and encapsulate it into a segment. So that is what is called adjacent layer interaction between layers on the same device. So same layer interaction deals with communication between different devices. For example, the application over here is going to be, we'll use Chrome web browser. And the application over here, we'll say this is a web server and he's running Apache. These are two different types of software, but they're used to communicate back and forth to each other, and they do that at the same layer across devices. So what's going to happen is it's going to go down the protocol stack, it's going to get sent over the wires, it's going to come up and talk to the other application and go back the same way which it came. So that's how layer interaction works. Let's talk for a second about that word encapsulation. So if you've ever seen the Russian dolls that you can put one inside the other, that's how you can kind of think of encapsulation with data going up and down the different protocol stacks. So you have one doll that goes inside the other doll, that goes inside the other doll, and each layer is going to add certain metadata, such as the network layer adding IP addresses and the data link layer adding the MAC addresses, and it's going to put other information on there as well, like on the transport layer it's going to add the sequence and acknowledgement numbers. to the segment. So in a nutshell, those are network models. I hope you learned something. Don't forget to like and subscribe, and hopefully I'll see you in the next video.